Hello, and welcome to episode 715 of the People Behind the Science podcast. I'm your host, Dr. Marie McNeely, and in this episode, we are rebroadcasting our interview with our guest, Dr. Molly Peeples, originally published on January 9th of 2017. Listeners, Molly's research investigates the origins and fates of heavy elements that were originally produced within stars in order to better understand how gases are flowing into and out of galaxies and to shed light on why galaxies differ from one another and how they've changed over time. And in this interview, Molly shared some excellent stories from her life and research. So get ready to learn more in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Joining me today, I have the wonderful Dr. Molly Peeples. So Molly, thank you so much for joining us on the show today. How are you?
I'm doing quite well. How are you?
I'm doing well myself, and I want to take a moment to introduce you to our listeners. So listeners, Molly is an Aura Assistant Astronomer at the Space Telescope Science Institute in Baltimore, Maryland. She received her bachelor's in physics from MIT, and she went on to complete her master's and PhD in astronomy at Ohio State University. Molly was then awarded a Southern California Center for Galaxy Evolution Fellowship, during which she worked at UCLA. In 2013, Molly joined the Space Telescope Science Institute as a postdoctoral fellow, and a year later, she became a member of the staff, and she continues to do amazing research there. And listeners, Molly is here with us today to talk about her experiences in life and science. So Molly, today we cannot wait to get to know you, both as a scientist, but also as a person. So can you start by telling us, what do you like to do in life outside of science?
Pretty much the same stuff people who aren't scientists do, I would say. I like to hike. It's one of the things moving to Baltimore I was very surprised to learn about is there are a lot of really good state parks near Baltimore. It's very easy to get outside of the city and into nature. I enjoy cooking, reading, spending time as far away from my computer as possible.
Mm-hmm.
And yeah, just generally checking out new cocktails and bars around town and playing board games with friends.
That's awesome. Do you have a favorite board game?
It varies a lot because generally whenever I find one that's like a new favorite, I'll get the iPad app and then I'll get obsessed with it and then it'll be impossible to play it with human beings again.
Mm-hmm. No one wants to play with you.
Yeah, so they kind of come and go. I think Dominion is the one that was my favorite for quite a while. And then I got an iPhone app version of it. And now you're used to playing a whole game in 45 seconds instead of half an hour.
Right.
No good.
Sometimes you need to get away from the screen too a little bit. I like to hear that you're interested in cooking as well. Tell me, do you have a specialty that you like to cook?
I've got quite a few things. I actually got a new oven 2 days ago. So Thanksgiving dinner was fun because I hosted Thanksgiving dinner without a working oven.
Oh, geez.
Turns out you can get really good deals on ovens on Black Friday.
That's awesome.
I inaugurated the new oven on Wednesday with a pretty phenomenal mac and cheese.
Oh, I like it. Well, Molly, congratulations on your new oven. And I think it's great to hear a little bit more about all these different things that you do in your life outside of science. And I love what you said there. I do what normal people do. And I think, right, that's exactly what a lot of scientists say. We don't do anything special when we're outside of work. But I do want to talk a little bit about your scientific life next. So you do some amazing work. Can you tell us, what is the high level description that you give people when they ask you that maybe dreaded question? What do you do?
I think there are probably three different answers, probably depending on my blood alcohol level.
Mm-hmm.
So
the cocktails you mentioned, yes.
Exactly. So broadly speaking, I am interested in understanding galaxies and why galaxies are different than one another, how galaxies have changed through time. And one of the main tools that I use for this is tracing the origin and fate of all of the heavy elements. So if you look at the periodic table, so hydrogen and helium were produced in the Big Bang that gave birth to the universe. Everything else was produced in a star. And so by looking at where the different elements have wound up, you can track how gas flows into and out of galaxies. So, for example, one of my favorites is oxygen, because every single atom of oxygen was produced in the death of a massive star. So they were produced in galaxies. But as it turns out, the vast majority of oxygen is nowhere near any stars at all, is extremely far away from galaxies, which implies there's some kind of large-scale process going on that's moving enormous amounts of gas outside of galaxies. So I spent a lot of time thinking about how to use these tracer particles, think of like marked bills in an economy, something like that, to track these large-scale gas flows into and out of galaxies. And then the other big piece of a lot of what I do is I am primarily a theorist. So I do a lot of analytic modeling. I do a lot of running and analyzing numerical simulations. And these are very useful for if I have a simulation and I'm, for example, trying to find the oxygen, I don't have to look very hard. It's all right there in the simulation, right? But if I then want to use that simulation to actually learn about the real universe, I have to do a little bit more work. So I'm really into taking these ideal, perfect, we know everything about them simulations and making fake data out of them, synthetic data that looks as much like the real data as possible.
Gotcha.
And then when you make the same measurements on the fake data and you compare that to what the input real answer is, you can actually figure out, well, what am I actually learning from the real data? Is it telling me what I think it's telling me or not?
Well, Molly, you've made this sound really exciting. You're like a galactic detective going out there, tracking and modeling elements. That sounds so cool.
It's pretty fun.
Well, I'm excited to learn more about your work as we go through the interview, but I want to take a moment to talk to you about motivation. I think it can be overwhelming, the amount of work that you feel like you have to do as a scientist. There's always more to do. And I'm one of these quote people. I love little inspirational sayings and quotes. So do you have one of your favorites that you could share with us today?
I've never really been into motivational quotes.
They're so awesome, though.
I think the closest one I have is more of a goading saying that some of my collaborators and I use, which is go big or go home.
Ooh.
And the corollary to that is sometimes we just end up going home.
Yeah. That's fair. Some days you just can't make it. You can't go big.
Yeah, like sometimes you try to get the big thing and then it just doesn't work. But it means that if you do succeed, that you've gotten something really big and awesome.
Absolutely. Well, I love that saying, Molly. And I'm curious, can you think back now over the course of your career? Are there any people that really come to your mind as people who inspired you or maybe motivated you to pursue science?
I've thought about this a lot because people like to talk about role models and such. And I think that there are quite a few individuals who I've learned to be able to look at and say that there are parts of what they do that I really aspire. It's like, okay, if I could hit that level of awesome, that'd be amazing. But then there are always other parts that it's like, I do not want to be like that.
You need like the Franken role model with pieces from a lot of different people.
Yeah, exactly. So I would say from a purely scientific perspective, there's a woman who actually died several years before I was born, who invented the field of galaxy evolution. Her name was Beatrice Tinsley, and she was just phenomenally brilliant. And actually, people who work in galaxy evolution joke that every idea you have, everything you do, it's like, well, didn't Tinsley do that in the 70s?
Oh, really?
Yeah, you can usually find the paper that says that, yeah, Tinsley did that in the 70s. And the computers weren't quite as good, and the models weren't quite as good, and the observations weren't quite as good, but she basically had all of the ideas there. And her papers are just amazing, and her writing is just amazing. And so even though a lot of it is very, very dated now, if I could be even a fraction as good at pulling together disparate ideas and combining them into some new insight, that'd be pretty awesome. She died of melanoma when she was 40. So it's really kind of terrifying to think how much more advanced the field of astronomy would be had she lived.
Certainly. Well, I think this is a great inspirational figure. Like you said, someone who seems to have thought of everything way before her time. So very, very cool to hear more about her. Now, can you tell us, Molly, I think this area that you're studying, space, the galaxy, is something that a lot of people get excited about. But what at first attracted you?
Yeah, so as a kid, I was never actually into astronomy. I remember other kids getting really into like memorizing the masses or whatever planets, and I was never that kid. I was very much into math. And then in high school, I did some science fair projects with the program I was in high school and decided that, okay, I wanted to do science research. Absolutely, that's what I wanted to do for a career, but I wasn't sure what field. I knew something with the physical sciences. I was never interested in biology, but I wasn't really sure what. So then in college, I thought I was going to go into just like raw physics, like particle physics or something like that. And there were kind of three things that happened all about the same time. So one is I had a particle physicist as an advisor who was, let's say, not a pleasant human being.
We all know at least one of those, yeah.
And really completely tore down any confidence I had in myself whatsoever. And I knew that I was better than what he was assuming or acting like I was. And at about the exact same time, I had a relativity professor who I was in the middle of flunking his class. But he was like, I don't understand how it's physically possible that you are managing to do this poorly on the exams, even though you clearly understand what's going on. And so that really helped. It's like, okay, if I'm going to spend time doing science, maybe I should spend time with people who are nicer rather than people who are not nice.
Right, right.
And then at about the same time, the WMAP-1 results came out. And these were the results from the Wilkinson microwave anisotropy probe, mapping the cosmic microwave background. And really, for the first time, nailing down a complete picture of the cosmological parameters that determine the geometry and expansion of the universe. And that was so fascinating and so interesting and so what I was looking for, that then when I was trying to pick a subfield of physics to go into, it was like very clear, like, okay, astronomy is the direction to go.
Gotcha. Well, Molly, it sounds like you had this almost perfect storm of motivating forces coming together. I like it.
Yeah, it's interesting how the timing works out.
Certainly. So can you tell us then, once you had decided this area of physics was what you wanted to go into, how did you proceed, or what happened next?
So that was my sophomore year of college, and I knew that I wanted to do a research project for the summer. There was actually a grad student, and I, for the life of me, cannot remember her name, who offered to sit down with me and help me figure out which professor to approach for a summer project. And we started listing every professor in the department who worked in astronomy, and every single one of them, either I knew they knew me and I assumed they would not be interested in working with me, or what they were doing sounded completely boring. And we finally found one name of one professor who, what he was working on sounded interesting, and I didn't know who he was. And right as we hit on that name, he's walking down the hall. And so she turns to him and she says, "Hey, Paul, do you want another undergrad for the summer?" And he's like, "Okay."
Wow. It seems almost too perfect.
Yeah. He's like, come to my office in 10 minutes. And by the end of the day, he'd hired me for the summer, and he wound up being my undergrad advisor for the rest of college.
That's awesome. So now you decided to go on to graduate school afterwards. What kind of prompted that decision, and how was your graduate school experience?
Well, once somebody actually told me, which I did not know as a naive undergrad freshman or sophomore, that it's typical to get a PhD if you want to have a career doing research professionally. It was pretty obvious to go get the PhD. And my grad school experience was very good. The Ohio State Astronomy Department was a very, very good fit for me. I very much did not like taking classes and did not really learn well in a classroom setting, and was very much ready just to do research. And the Ohio State astronomy philosophy very much fit that. The classes were geared less at divesting knowledge and more at, here are the vocabulary words that you can understand and follow in conversation about astronomy. And if you need to know more, or if you need to know more details, here's how you can go about getting that information. And the information that you need to know off the top of your head and have memorized, you're going to naturally learn by doing research anyhow. So that really suited me. And so I was able to work on many different topics with many different people. One of the things I really love about astronomy is that you don't have to specialize if you don't want to. And one of the things that worked well at Ohio State is you didn't have to start working with one person your first year in grad school and work with only that person the whole way through. So I was able to learn not only different subfields of astronomy, but also different working styles and different ways of doing things rather than just...
Right, picking one person and
Yeah, and there are a lot of people, if you ever only going to work with one person in grad school and you start your first year, you don't get along with that first person that you happen to end up with.
It could be a long couple of years. Or
And I think there are a lot of people who end up thinking that they're not cut out for it or something like that, whereas really it's just a personality difference.
Sure. So now you went on to do a postdoctoral fellowship at UCLA and then another one there at the Space Telescope Science Institute. Can you tell us about these postdoctoral experiences?
Yeah, so the one at UCLA was pretty unique. It was a bit of an experiment. So I was based at UCLA, but I spent a decent amount of time at UC Santa Barbara and also the other Southern California Center for Galaxy Evolution schools, UC Irvine, UC San Diego, and UC Riverside. So there were other fellows at some of those other institutions. So part of what we were trying to do was there were only a few people at each school working on galaxy evolution. But combined across the 5 schools, it makes for a pretty formidable group of people working on a lot of interesting things, just separated by a little bit of distance. So a lot of what I was trying to do there was try to bridge those gaps. And it sort of worked, sort of didn't. The downside was that I had a lot of ideas and a lot of things I was trying to pursue and not much focus.
Right. The shiny object syndrome, I think many of us have had experience with.
And the people who were most likely to act as mentors for me were not at UCLA. And so even though I had the scientific drive, I didn't have anyone sitting there telling me you should maybe instead of pursuing this thing, just stop and finish this one paper first. Mm-hmm. So the first postdoc was definitely a time of figuring out what I was interested in and what direction I wanted to take career-wise, not just scientifically. And that's definitely a thing as a grad student, I was completely unaware that your scientific interests or your scientific direction can be different than trying to map out your career, which even as I say it, sounds like a pretty subtle distinction.
Mm-hmm. So then tell us about the Space Telescope Science Institute. How is it maybe different from a traditional academic environment, and what's it like there?
Well, the really big difference is that we don't have students. So I'm on the tenure track, but I don't teach. And so I have 50% of my time that's research, and the other 50% is supporting space telescopes. So the main ones that we're known for is we're the science home for the Hubble Space Telescope. And we will be both the science home and the base of operations for mission control for flight operations for the James Webb Space Telescope, which launches in less than 2 years.
Very cool.
And we host the archives for Hubble and several other space telescopes. We'll also host the archives for JWST. And we're also heavily involved with the planning and mission design for other future space telescopes.
Gotcha. Well, it sounds like a fantastic place to work. And can you tell us about one of these projects that you have going on that you are so excited to be working on?
So one of the projects that is part of my time is working on planning for WFIRST, which is let's see if I can get this correct, the Wide Field Infrared Survey Telescope. It's also a really horrible pun because one of the things that this telescope is aiming to do is to really improve our knowledge of dark energy. And one of the main parameters that it's going to be attempting to measure with respect to dark energy is the variable that's used for it is W.
Ooh.
Yeah.
I'm going to say knowing this makes me appreciate it that much more. I love bad puns. So
cringeworthy. Yeah. And so this is set to launch about mid-2020s, and we're in a very exciting stage of it right now because we are officially in what's called Phase A or formulation, which means we're an official mission, we have an official budget from NASA, from Congress, and so we're in the process right now of writing all of the requirements documents. The other thing about this telescope that makes it very unusual is it was originally kind of scoped and planned out for being a 1.3 meter diameter telescope. And then the NRO, the National Reconnaissance Organization, knocked on NASA's door and was like, hey guys, we've got these 2.4 meter telescopes lying around that we can't really tell you what they were designed for, but do you want them?
Oh, wow. That is something you do not say no to.
So NASA's like, yes. So back to the drawing board. And so now we've got this telescope that the mirror is the same size as that of Hubble's, but the geometry is slightly different. And so the amount of sky that it can see in one pointing and one go is 100 times bigger than that of Hubble's.
That's incredible.
So it has the same resolution. It can see the same size structures, basically, but a whole lot more at once. It's going to be a very versatile mission. It's pretty interesting. So it's going to do this dark energy study, looking at distant galaxies and supernovae. It's going to be looking for planets at the center of the Milky Way. And it's also got a separate planet imaging mode. But 1/3 of the time for it is still going to be like that of Hubble's, where the community can write proposals and apply for time to use the telescope to do their own science. And so that's going to be just very, very powerful. There's going to be a lot of interesting stuff that can be done with that. So one of the things that I'm doing with that is we have a simulations group that is doing some of what I was telling you about earlier of making mock data that is going to look like the real WFIRST data so that we can actually say, okay, we're saying this telescope is going to do all these things. If we have this exact detector technology or this exact survey strategy, are we actually able to then do the science that we want to be able to do? Or how far can we push the science that we want to be able to do? Or how well will this data be able to distinguish between different models for other purposes?
Definitely. Well, Molly, this sounds really, really fascinating. And I'm curious to see what comes out of these telescope missions. Is there something that you're maybe expecting or hoping to see when the data start coming back to you?
I think for WFIRST, one of the things I'm personally really interested in is their structures in the halo of the Milky Way. So when you look at the Milky Way in the sky, you see this band of stars that's very, very thick going along, and that's the disk of the Milky Way. So if you think of your traditional picture of a spiral galaxy, right, there's this area where it's very clear that all of the stars are in this pancake spiral structure. Mm-hmm. But they're actually stars that extend, albeit at very low densities, far away from that disk. But you need something that's both very sensitive and can see very deep to see these faint stars, but also has a wide area in order to detect, detailed structures. And I think WFIRST is going to be really, really powerful for finding some of these structures in the Milky Way's stellar halo that you just wouldn't be able to get otherwise. But I think that's going to be definitely one of the interesting applications.
Gotcha. Well, Molly, you are making your research sound like such an exciting adventure, but I have to imagine that there are downsides too, right? Everything can't go amazingly well all of the time. And I love talking about some of these challenges and failures and struggles that scientists face, because I think it is really important to give everyone out there an idea of what life is like as a scientist, and maybe not through the rose-colored glasses. So do you have a challenge or a struggle or a failure story that you can share with us today?
Yeah, so I'll mention one that was a little bit ago, and then another one that's just kind of an ongoing daily struggle.
Sure.
So when I moved from UCLA to Space Telescope as a postdoc, that was a very, very difficult time because I had a 3-year postdoctoral position at UCLA. And so nearing the end of those 3 years, I applied for a few dozen jobs and proceeded to get shortlisted on 3 or 4 of them. And then I got no offers.
Oh, dear.
And the way that the academic calendar works is there's like one shot for applying. And if you don't get anything in that round, you're SOL. And right around the same time, all of my friends who lived in Los Angeles either had just moved out of town or were going through their own personal struggles. And so I had no one to talk to about anything. I'm sitting there thinking this was going great, and now I've got to figure out another career.
Right. What do I do?
Like, now what? But luckily, I had contacts and I had mentors elsewhere who I was able to say, like, this is what's happening. And one of them, who is a colleague here at Space Telescope, was able to scrape together enough money, found some money under his desk or couch or something.
Right. Begged his neighbors, yeah.
Yeah. To fund me for a year. So then as soon as I arrived in Baltimore, I started applying for jobs again. I started working on job applications before my stuff even arrived from California.
Oh, wow.
Yeah. So that was a pretty difficult time because you think this is what you're going to do with your life. And then you're basically being given the message that actually, no, you have to go do something else. And I had never even thought through the process of like, what else could I do? What else am I qualified for? Which is something I think that any scientist should do at basically every stage of their career, if only so that they know that being in science is an active decision instead of a passive one. But yeah, that was definitely like the lowest point of all the points.
Yeah. Well, I think sometimes not having that backup plan kind of forces you to make it work, which it sounds like in this occasion it worked out well for you.
Yeah, I definitely really, really lucked out. And then the fact that I did get my number one choice of job the following year was really, really big turnaround and fortunes there.
Absolutely.
I mean, in my day-to-day life, the balance between, I call it the work-work balance, the balance between doing my science, which is why I got into this mess in the first place, and doing, we call it the functional work, doing the work of supporting the Hubble mission and working on W first and these things that have more pressing deadlines. There are people knocking your doors asking if they can have a second for this or that, and are much less open-ended than sitting down and trying to solve a problem with the universe.
Mm-hmm.
I probably have a conversation about how difficult that is to balance once a day.
So what do you do? What helps you balance it?
I've tried a lot of different techniques. So one of the things I've learned over the years is I work well when I talk to others. And so having other people to bounce ideas off of was like, oh, well, I told so-and-so I was going to have a result for them, or like, oh, so-and-so is really going to find this plot interesting or whatever. That helps. And then it's also just trying to break down the big tasks into smaller pieces so that it doesn't feel as open-ended. So very meticulous outlines and to-do lists tend to help.
I'm totally a fan of these meticulous to-do lists. I know if I put like 1,000 things on my list, I'll feel really accomplished, even if I only get like 20 of them checked off. Like, I did 20 things today.
Yeah.
Never mind that one of them was like eat breakfast. But
Step one, write to-do list.
Yes, done. Well, Molly, it sounds like you were able to come up with very functional solutions to these challenging problems. Not just the kind of everyday struggle that you mentioned here, but this big career turning point that you were at when you were in this postdoctoral position. So congratulations on turning those challenges around. And I love talking about the successes in science, and it's fun to celebrate them. So I want you to share with us, Molly, today, another story of success.
One of the more recent successes that it probably didn't even feel like it was at the time was I spent most of the summer co-authoring a very long review article, and it had a much stricter deadline than we were expecting. It was an invited review article. And so the deadline they'd given us was on a Thursday. And so we're like, that's nice. We'll turn it in on Friday. And on Tuesday, we found out that, like, no, really, they wanted it by Thursday.
Thursday is the only option.
And we'd been working on it for like months at this point.
Oh, geez.
Yeah. So, I mean, we managed to get it in on Thursday. And at the time, it felt very anticlimactic because we knew we'd be able to edit it and change it in review. But now that it's a few months past, it's like, yeah, that was a really nice article. We have some really gorgeous graphics and figures. And when going through all of the material, we were able to really think about the field from a more holistic and different perspective than we otherwise would have just by focusing on our own stuff. So that took a little while. We still haven't gotten the review back from the journal, but that felt really good to be able to actually be like, oh yeah, we spent a few months working really hard on this thing. And even though no one's read it yet, it got some pretty obvious payback.
Gotcha. Did you anticipate when you first got that invitation, maybe how much work it would be or how rewarding it would be at the end after you turned it in?
Oh, we knew it would be an enormous amount of work.
Yeah.
Yeah. But we also knew that it would be completely worth it. Plus, they give you a mug when you publish in their journal. So,
ooh, describe this mug for us.
Apparently, it changes every year, and ours hasn't been published, so we don't know what the mug looks like yet.
So it's a mystery mug. Well, you're going to have to update us once you get this mug. Send a picture.
Okay.
Well, Molly, this sounds like an amazing success. And I know when you kind of are pouring months of your heart and soul into writing a paper, writing a grant, whatever it might be, it's just that feeling of relief when you push the send button, I think is amazing.
Yeah.
So Molly, we've talked about different aspects of your science, but also your life outside of science. And in the beginning, you mentioned that you love to read. So do you have a book recommendation for us of something you've really enjoyed that you think we all should check out?
Yeah, so I recently finished the 3-Body Problem trilogy, which if you or any of the listeners have read, you'll know it was a very interesting thing to read during the recent election season. It's a trilogy written by a Chinese author that only in September was the final book of the trilogy published in English. So for English speakers, it's a very different perspective than most science fiction that we would read. I would say as a recommendation, if you do not know the premise of the trilogy, don't find it out. Just get the book and read it. Because a lot of the mystery and interestingness that makes the first book really awesome is trying to figure out what the hell is going on.
All right, well, listeners, no spoilers here.
Yeah, no spoilers. But, for example, one of the things that makes it really fascinating is The first book starts off set during the Cultural Revolution in China. And I learned more about that period of Chinese history through reading the footnotes of the first 2 or 3 chapters than I had ever before. And the main character in the first book is a female astrophysicist. So it's not much of a spoiler. But
near and dear to your heart, yes.
It was a really, really fascinating trilogy with lots of twists and turns. And I would just say anybody who's feeling down about 2016, go read this trilogy.
Awesome. Well, you've got our attention, Molly. I will definitely put this out on our website for our listeners to find, the 3-Body Problem trilogy. So thank you for sharing that recommendation with us today. And I know we've chatted a little bit in our discussion about your career path, about some of the different moves that you've made, the different places that you've gone for your scientific career. And I think travel is part of the life of a scientist. So is there one travel experience, one trip that you've been on, Molly, that really sticks out in your mind as your favorite? And is there something about it that you'd like to share, maybe why it was so memorable or special for you?
I think the place that I've traveled for science that sticks out in my mind the most was I went to a conference that was in the middle of nowhere, Tuscany, which was one of these places that here sounds like a total destination conference, but it was people working on chemical evolution, astrochemistry, and it turns out that a lot of the leaders in that field are in Italy. So they picked this amazing location that was a space that used to be a monastery. And they had bought up a bunch of the neighboring farms. So the actual conference, it was only about 60 people, was held at the main monastery area. Then we all stayed in these farmhouses, only about 8 to 10 people per house that were 15 to 30-minute walk away, just overlooking the Tuscan countryside. The Wi-Fi was horrid.
Yeah.
So you're completely out of touch with the outside world, which the only way in which that could have been better is if they'd advertised ahead of time, you're not going to have internet.
Right. Leave an away message. Yeah.
Yeah. And every meal was the best meal I'd ever had until I had the next meal. And then I was like, oh my God, this is the best meal I've ever had. There'd be both the white wine and the red wine and the dessert wine with lunch and dinner. And just the setting and the size of the conference made it so that your interaction with each other is just so different than if you're in a stilted auditorium or
a hotel ballroom.
Yeah,
right.
Exactly. And the other thing is that a lot of times you go to a conference and you're just stuck inside all day. And so you're surrounded by this amazing countryside. That was a pretty phenomenal conference.
And I think you're forced to enjoy that countryside because you had that 15 to 30-minute walk from where you were staying.
Yeah, they did have shuttles if we wanted them. But if you wanted to have time to go swimming during the lunch break, you would probably not want to walk.
Yeah, that's true. Got to use your time wisely in these conferences.
Exactly.
Now, you mentioned the food, and I know as someone who loves cooking, was there one dish that stood out to you the most, or one that you want to describe to us that was just amazing?
I can't even remember. I mean,
it blew your mind.
Yeah. It was the final night of the conference. They had this walking buffet. They led us into the cellars, and each room you would go into would have a new thing of amazingness. And one of them was fried quail eggs that they would fry right in front of you. And I had never even known that quail eggs were a thing.
Were they good?
I probably ate 7 or 8.
Yeah. I guess they were good.
They were so good. The other one was the dessert wine. Was this very sweet wine. It was very golden, and it was just very distinct. And I got to calling it the wine of the gods because it was just so good.
Ooh.
And I found out a few days later when I was in Rome for a little bit afterwards, I found out that the style of wine is actually called Vin Santo, so sainted wine.
You are not alone in this belief, yeah.
And it's something that to try to get in the States, it's $80 for a half bottle.
Oh my gosh. It's a good thing you appreciated it then in there.
Yeah, it's not really brought to the States.
Gotcha. Well, Molly, this sounds like a phenomenal trip. And I think the environment of these conferences oftentimes contributes a lot to getting people to open up, getting people to be more free with sharing their science, talking to people, walking up to a stranger and just initiating that conversation. So I think that's awesome. So now we've talked a little bit about some of the people you've been able to work with over the course of your career. And I think some of the people that you interact with in science is kind of part of what makes it so great. And each of the different labs that you work in has its own personality and oftentimes quirky traditions that go along with it. So Molly, do you have a memory of maybe a quirky tradition that you participated in, or just a fun or funny memory that you shared with some scientists that you've worked with that you can tell us about today?
Does texting each other pictures of martinis after finishing proposals and papers count?
Yes, absolutely. Why martinis?
Because gin is delicious.
It's no wine of the gods, but yes.
Yeah, I figure, you're working with the correct people when you've been really pushing towards a deadline with people and exchanged hundreds of emails with them in a week. And then after the deadline, you still feel the need to be like, look at my celebratory drink.
Yes. Is this something that is a tradition now where you're at the Space Telescope Science Institute?
I don't know about traditions. There's probably a lot more things that I probably consider very normal now that an outsider would probably be like, that's a little quirky. But nothing really comes to mind off the top of my head.
Gotcha. I think it's easy to get used to some of the quirks that you have in your life.
Yeah.
Well, fantastic to hear about this lovely texting of celebratory beverages. I think this is something that a lot of labs can perhaps adopt. Well, Molly, thanks so much for sharing this tradition. And I know we've talked about some of the scientific questions that you're working on, some of the fantastic things that these telescopes are going to be able to do for us with these different missions that are going out. But I want to know, what is this big question that you have burning in your mind still that has not yet been answered? So if I gave you everything like funding, staff, technology, feasibility, sky is the limit here. What is the question that you would want to answer?
So my main burning question that I spend most of my time thinking about is trying to understand the structure and dynamics and underlying physics of what's known as the circumgalactic medium. So this is the diffuse gas that surrounds galaxies. So to give you a sense of scale, a galaxy like our own Milky Way would have a radius of about 10 kiloparsecs, or a kiloparsec is about 30,000 light years, I think. Whereas the circumgalactic medium can extend out to 300 kiloparsecs. So the actual area where the stars is in the whole galactic ecosystem is actually very, very small. And this is the area that everything having to do with galaxy evolution depends on the circumgalactic medium. So galaxies need gas in order to form stars. They get that gas from the circumgalactic medium. Galaxies, if they stop forming stars or as they form stars, re-expel a lot of gas and those freshly produced heavy elements that I was talking about earlier back out into the circumgalactic medium. But because this gas is so diffuse and doesn't have these nice bright stars lighting everything up, we know very little about it, and our current techniques for learning about it, we're only able to learn about through these one-dimensional pencil beam skewers. And it would be really amazing to have like a full three-dimensional map of what was going on. So if you think of pictures from the Hubble Space Telescope of like the Orion Nebula, where you see all these bubbles and turbulence and bow shocks and all of this really amazing stuff that's going on in the interstellar medium, the gas inside of the galaxies. It would be really lovely to have that degree of information for the gas outside of galaxies, which is kind of the puppet master for what's going on inside of the galaxies. But in order to do that, we need not only much, much bigger telescopes, because there are just so many fewer photons coming from the circumgalactic medium that we need a bigger light bucket, but also the telescope has to be in space because, as it turns out, the physical conditions of the gas means that it's most readily observable in the ultraviolet. And thankfully, we still have an ozone layer, and so those ultraviolet rays don't make it to the Earth. So you have to go to space in order to observe them. So it's technologically challenging, may or may not happen in my lifetime, but that's my dream observation, to understand actually what's going on out there instead of trying to piece it together for these small nuggets.
Definitely. Well, Molly, this sounds like a really exciting question. And I know for people who maybe don't work in this area, it's hard to wrap your head around some of these distances and just the big scale of the problems that you're studying. So maybe can you give us a flavor of, when you talk about galactic evolution or the evolution of galaxies, what are you referring to? What sorts of things are evolving? Is it just kind of the gases flowing in and out, formation of stars?
Yeah, so as the gases flowing in, stars are forming. As stars form, the sheer pressure from the radiation from the hot stars can push some of the gas back out of the galaxy. And then as they explode as supernovae, all of that heat and energy that's deposited back into the gas also pushes the gas back out of the galaxy. So there's kind of this recycling of gas in and out. But also galaxies today look very, very different than galaxies did when the universe was much younger. So they aren't forming stars as quickly. The disks tend to be a lot more ordered and have this nice spiral structure instead of being these chaotic, turbulent things that we had in the younger universe. So when and why did that transition happen? Today, there are galaxies that are a huge range of different masses, of different sizes, of different shapes. Why is that? Why are some galaxies forming stars at different rates and in different ways than other galaxies?
Gotcha. Well, very cool to hear more about your work and one of these big questions that you are still working to answer. And throughout your scientific career, you get to work on a lot of these exciting questions, and you get to work with some inspirational and wonderful mentors along the way. Is there maybe one person you can remember who gave you a particular piece of advice that was so helpful to you in your career path that you can pass on to our listeners today?
So I don't remember who I heard this from, but I would say the best piece of advice that I try to stick by now is work with the people who you want to work with. If you got into science because it's something you enjoy, that doesn't mean that you should work with people who make your life miserable. And if you can work with people who you genuinely enjoy spending time with, who you genuinely enjoy working with, who you genuinely enjoy solving problems with, then your enjoyment of your science and your career will be much, much higher. And who those people are, what kind of personalities those are, will vary from person to person. But it doesn't matter how big of a name somebody is or how crucial to your work you think somebody is. If they're a destructive personality, or they're someone who's going to shoot you down at every step of the way, or if your personalities just don't jive, if you're the type of person who, when you ask a question, you want a one-sentence answer instead of a 1-hour explanation,
you will be infinitely frustrated. Yeah.
Right? Maybe you don't want to work with somebody who's a big talker, whereas I love asking a question and getting a 1-hour explanation. So I can get along with those people. But I think all too often people fall into this trap of working with people who are just not adding goodness to their lives. And it's a significant fraction of your waking life. And so try to surround yourself with people who you actively enjoy being around. And if you discover other scientists who you realize you really enjoy spending time with, who you're not working with, maybe sit down and be like, hey, we should totally write a paper together. Let's come up with something. Those are the people who you should pursue collaborations with, not just the people who you think you should be because of some other external forces.
Well, Molly, I love this advice. And I think it ties in well to that story you told earlier about that anti-mentor in undergraduate. You decided, this isn't a person that I want to be around. I'm going to tweak my career path, make some changes to make it so that I'm able to work in an environment where I like the people that I'm surrounded by. So I think that's a helpful message to pass on to our listeners today. So is there any last message you want to leave them with, or a last note of inspiration that you'd like to end our conversation on today?
The only other thing in the same vein that it took me quite a while to realize, and I don't have tenure yet, so I can't actually say whether or not this works out, is I do science and I do astronomy because I love it and because I find it fascinating and I find it fulfilling. But at some point, I decided how much of myself I was willing to give the career, how much of my nights and my weekends and my emotional energy, et cetera, that I was willing to give. And I try really hard to not give more than that. And if I can make it doing that amount, then fantastic. And if I can't, then I know that I haven't lost some of myself along the way. Whereas if I could only make it by giving so much of myself that there's not time for me to be me outside of my career, then I don't think that would count as a win.
Certainly. And I think this is a really important message to share, because it can be daunting if you're in an environment where there are people who are completely happy to dedicate 100% of their life to their work. And you feel like, I don't want that. Is that what I have to do to be successful? And in most cases, you can have that work-life balance.
Yeah, so it really chafes at me when people say work-life balance, because it implies that our work is not part of our lives, right? Even if you only work 40 hours a week, that's a significant fraction of the time that you're awake, right?
Mm-hmm.
And this is, I think, one of the reasons why the biggest career lesson I've taken to heart to date is this idea of working with the people who I want to work with. Is that, yeah, I have a life outside of work and outside of my career, but that doesn't mean that the time I spend working isn't a huge part of what I'm doing.
Right. It's also part of your life. Absolutely. Well, Molly, I think that is a great note for us to end our conversation on today. Can you tell our listeners, if they want to learn more about you and all the fantastic work that you're doing, where should they go?
Probably the best place to find me is on Twitter. And my Twitter handle is Astronomy, ASTRONOMOLLY.
Fantastic. Well, listeners, definitely follow Molly on Twitter. Stay up to date with all the fantastic stuff that she is working on. And Molly, thank you so much for joining us on our program today and sharing a piece of your story.
Thank you. It was a lot of fun.
Well, it was a pleasure to have you here. And listeners, a pleasure to be with you as well. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.